Hello, this is Brian with Gooseneck Implement. In this video, we'll take a simple approach to setting up section control in an air cart. Items like section equalizer times, mechanical delay times, in-field tests, and then making adjustments after the in-field test. The first step of setting up section command on an air cart is accessing the section command menu. In the section command menu at the bottom, I have my inner and outer on and off times. If I turn the page, I have the option for my mini tank, front tank, middle tank, and rear tank times for the outer and inner runs. Looking at the outer run, turn on time. At the furthest opener out on the wing, how long does it take from seed to leave the meter and have adequate flow coming out of the opener? The turn off time is how long does it take from when the meter stops spinning and adequate flow is diminished. The inner turn on time is the shortest run in the midframe. How long does it take from seed to leave the meter and have adequate flow coming out of that opener? The best way to obtain the inner and outer on and off times is to utilize two people. One person at the meter activation switch waiting for the signal to turn on or off, and one person at the opener with a stopwatch to time the flow of seed. Once the on and off times are obtained, we will enter these values for all tanks. The times entered for the inner and outer runs are also known as equalization times. These inputs allow the cart to control the individual primary gates in the meter at different times to create an even distribution across the tool. Once the equalization times are entered into the air cart settings, the operator also needs to enter the times into the equipment settings. The fastest way to get into equipment settings is using the shortcut Setup. In the work setup, access the equipment and choose Air Cart Seeder. Times are entered into the implement settings as mechanical delay, on and off times. If I scroll down, here's my mechanical delay. According to the book, the mechanical delay, turn on and turn off, is the same as the outer run from section equalizer. Just like work point measurements, these times work with the guidance receiver and tell the cart when to initiate the individual primary gate sequence. Mechanical delay times are adjusted to increase or decrease coverage. Once the values have been entered for section equalizer and mechanical delay, I need to turn on a feature within section control. In the menu, Applications, and Section Control app, I'll access the advanced settings. Within the advanced settings, there's a feature called Visualize Mechanical Delay Look Ahead. Turning this on gives the operator a sense of how section control thinks. Using the measurements and the turn on and turn off times, how does the air cart know when to turn on and off? And what can I do to help that process? And the main way I can help is keeping a consistent drive speed. If I close all these tabs out and go back to my guidance map, you can see I now have an orange bar in front of the tractor. These dashed lines go back to the work point where seed is getting placed. What this tells the operator is once this orange bar hits coverage, I cannot increase or decrease speed because it will affect the section control. If I increase speed, you can see how that bar moves. If I decrease speed, you can see how the orange bar moves. Having this feature turned on will help the operators know that once this orange bar has reached coverage, I cannot increase or decrease speed. This will give me the best performance while using section control. The next step is to verify our times. We'll verify the times with an in-field test. First, we need to simulate a headland. We will need a minimum of 3 passes so we have enough room to do a complete turnaround while entering and exiting the headland. While making the 3 passes, we will need the disc in the ground to have a cut mark or some point to measure from. After the headland passes are made, We will then enter the headland perpendicular with our discs up. Using the master switch on the display, we will activate the main drive. Blowing seed on top of the ground allows us to do an accurate measurement of our skip or overlap. The operator must maintain consistent drive speed while entering the headland. Perform a U-turn and then exit the headland at a consistent speed to then measure our skip or overlap while exiting the headland. After completing the first test run, we need to mark seed placement across the width of the drill for entering the headland and exiting the headland. As you can see, we have marked seed placement with pink ground paint. The markings give us a visual to how the section equalizer times allow a more even distribution across the width of the tool. We call this our chevron or V pattern. The ideal chevron pattern can be 2 to 3 feet from the outer runs to the inner runs. If the chevron or V pattern is too aggressive, adjustments need to be made to the section equalizer times within the air cart settings. With an acceptable chevron or V pattern, measurements need to be made from the headland marking to the chevron or V pattern. This will determine the amount of coverage or a skip. The amount of coverage needed is determined by the customer. In this illustration, you can see that we have a skip entering the headland. To fix this skip, we will use performance tuning. To access performance tuning, we'll go to the main menu, and in Applications, we will have an app called Section Control. In Section Control, we have our master on and off, but also down here we have the tanks that we can choose to either enable or disable section control. If we scroll down, we will use the rear tank. Looking at the rear tank, you see we have overlap settings, but we also have performance tuning. Using the performance tuning feature, I then give it the values needed. So we had a skip entering the headland. Right here I have the bubble into skip, and then I need to tell it the distance of the skip. Now looking right here and looking at the illustration we just showed, there was an 8-foot skip right to the headland. If I put in 8 and hit OK, I also need to put in a value for the speed. 4 miles an hour. Once those two values are in, I can hit the OK button, and then it will adjust my turn on and turn off times. Down here you can see the pre-tuned off was 3 seconds. The post-tuned off is going to adjust to 1.64 seconds. Now these times are the mechanical delay times located within the equipment profile or the implement setup. Once that's closed out, if I go back into my equipment, you can see that the mechanical delay for the rear tank was adjusting according to the performance tuning. In the performance tuning app, let's talk a little more about the symptoms. Looking at the entering coverage, if I leave it as a skip and I go into the distance, I must remember that the distance is from the headland to where the skip is. If I want additional coverage, I need to add that distance into my skip. In the previous example, we said that it was 8 feet from the skip to the headland. If the customer desires 4 foot of coverage, my 8-foot skip is now a 12-foot skip, and that adjustment will be made to the mechanical delay. Please make sure that the customer lets you know what the adequate amount of coverage will be. Once the adjustments have been made, we then need to do another field test of entering and exiting the headland. In this video, we learned how to accurately obtain our turn on and turn off times for our inner and outer runs, the purpose of mechanical delay, how to properly perform an in-field test, marking seed placement, and then measuring our markings to determine our coverage or skip, and how to adjust our coverage or skip using the performance tuning application.